Multiplication and division of rational expressions. Now remember, rational expressions are fractions. Do you remember how to multiply fractions? To multiply fractions, it's top times top, bottom times bottom. What about dividing fractions? What do you do? To divide fractions, you multiply by the reciprocal of the second fraction. Example 1. The direction says to multiply. For A, we have the fraction 6x plus 6 all over 7 times 14 all over x squared minus 1. Well, the first thing is we merge the two fractions together. We do top times top and bottom times bottom. From here, we need to factor each individual piece. So first, looking at 6x plus 6. On the side of our paper, we are going to factor that. Now, anytime you're factoring, we always start with, do they have anything in common? And if you notice, 6x plus 6 both have a 6. So we factor out a 6 and we have now 6 times x plus 1. So we currently have two factors, but can either of them factor down again? And it turns out the 6 is actually made up of 3 times 2. Now x plus 1 is linear, meaning it's a plain x and it will not factor anymore. So we can now write this in factored form as 2 times 3 times x plus 1. Now we're going to factor the other numerator, which happened to be a 14. 14 is made up of 7 times 2, and both 7 and 2 are prime numbers, so they are done factoring. We can now write them together. Next, we're going to try to factor the denominators, and we first have a 7, and if you notice, 7 is prime, so it cannot factor, so we go ahead and include it in our factored form. And then the other denominator of x squared minus 1, if you notice the pattern, that is known as the difference of squares, which means I have a perfect square minus another perfect square. And when that happens, you can instantly write it in factored form as x minus 1 times x plus 1. And notice x minus 1 and x plus 1 are linear, so they are completely factored. And now we can write that in the factored form. Once we have everything factored, now we want to reduce. To reduce, you look for factors that appear in the numerator and in the denominator. Do you see anything? And you'll notice x plus 1 appears in both places, so they reduce to a value of 1. Is there anything else in common? You may notice the 7s. They also reduce to a value of 1. Is there anything else? No, which means our answer will be whatever is left over. In the top, we have a 2 times a 3 times a 2, which gives us 12. And in the denominator, we have x minus 1. So our final answer is 12 all over x minus 1. Example B, we have the fraction 4x plus 8 all over 7x squared minus 14x times the fraction 3x squared minus 5x minus 2 all over 9x squared minus 1. So again, the first thing is to do top times top, bottom times bottom, which just means get everything in the right location. Once it's in the right location, now we want to start to factor each individual piece. So on the side of your paper, we look at the first numerator, which is 4x plus 8. And we begin factoring. We notice they both have a 4 in common, so we factor out a 4, which leaves you with an x plus 2. 4 is not prime, so 4 can factor down to 2 times 2, and then we still have the x plus 2. From here, we have completely factored that part of the numerator, so now we rewrite it. Looking at the other numerator, On the side of our paper, we have 3x squared minus 5x minus 2. First we look, do they have anything in common? And they do not. So you move on to the AC method, doing your first times your last and expanding. Expand to have 4 terms. From there, do factor by grouping. And in the end, you should find the 2 factors of 3x plus 1 and x minus 2. And since both pieces are linear, they are completely factored. So we include that in our factored form. Now that we have factored the numerators, let's look at the denominators. We have a 7x squared minus 14x. And so hopefully you notice they both have a 7 and an x in common. So we have 7x times x minus 2, but 7x can be factored into a 7 times an x, which is still multiplying the x minus 2. Now that it is completely factored, we can include that in the factored form. And then the last denominator is 9x squared minus 1. Now this is a quadratic because it has x squared, but I want you to look at the pattern. Notice 9x squared is a perfect square, 1 is a perfect square, and there is a minus in between, which means this is the difference of squares. So we can instantly factor it into 3x minus 1 times 3x plus 1. And now that we have all the pieces factored, now we want to reduce. Is there anything that appears in the numerator and in the denominator? And you will notice there's a 3x plus 1 and an x minus 2. Anything else? There doesn't appear to be. So your final answer would be 4 times x plus 2 all over 7x times 3x minus 1. Example C. Negative 5a cubed divided by 3b cubed times the fraction 2b squared divided by 15a. So our first step is to do top times top, bottom times bottom. From here, now we need to factor. Your first numerator is negative 5a cubed. You're probably wondering, well, what do I do with that negative sign? Well, we rewrite it as negative 1 times 5a cubed. Now we concentrate on the 5a cubed part. We're going to separate that into a negative 1 times a 5 times a cubed. 5 is prime, so now we look at the a cubed. A cubed really means a times a times a. So now we have that piece completely factored. The other numerator is 2b squared. 2b squared first gets rewritten as 2 times b squared, but we know b squared is really b times b. In the denominator we have 3b cubed, so first we write it as 3 times b cubed. And again, we know b cubed really means b times b times b. And lastly, we have 15a. We write it as 15 times a, but 15 is not prime, so we write it as such as 3 times 5 times a. And now all pieces are factored. Now we carefully reduce and find common factors. And first you will notice we have 5's in common, an a in common, a b, and another b, which leaves our final answer to be negative 2a squared all over 9b. Here is your try it problem. Let's see how you did. First, you should have done top times top, bottom times bottom. On the side, you should have factored all 4 pieces. And then when you reduced, and your final answer should have been a plus 3 all over a plus 2. Example 2. The direction says to divide. This time, for example A, we have 2x squared minus 5x minus 12 all over 6 divided by the fraction 3x minus 12 all over 2. Now remember, to divide fractions, we multiply by the reciprocal of the second fraction. Reciprocal simply means to flip the fraction. So now that it is rewritten, it's now written in terms of multiplication. We know how to do that. So we know that from here we multiply top times top, bottom times bottom. Then we begin to factor. So on the side of our paper we factor the first numerator. 2x squared minus 5x minus 12. First we look, do they have anything in common? And they don't. So then we move on to the AC method. We expand it. We then do factor by grouping. And in the end, we should find the factors of 2x plus 3 and x minus 4. The other numerator was a 2. 2 is prime and cannot factor, so it will remain a 2. Now looking at the denominators, the first denominator is at 6, which is not prime, so we factor it into 2 times 3. And then the last denominator is 3x minus 12, and we always ask, do they have anything in common? And they do. They have a 3. So rewritten, we have 3 times x minus 4. Once all the pieces are written in factored form, now we're ready to reduce. So carefully look in the numerator and the denominator and see what can reduce. We have x minus 4's and a pair of 2's. And so we are left with 2x plus 3 all over 9 as your final answer. Example B, 10x plus 4 all over x squared minus 4 divided by the fraction 5x cubed plus 2x squared all over x plus 2. Now again, we're being asked to divide two fractions, and when you're being asked to divide, you must multiply by the reciprocal of the second fraction, so you have to flip it. From here, we are now multiplying, which means top times top, bottom times bottom. Now that we have everything in the right location, let's begin to factor. So again, on the side of your paper, start factoring. 10x plus 4, you always ask first, do they have anything in common? And they do. They have a 2, which leaves you with 5x plus 2. Next we have an x plus 2. We check, do they have anything in common? No. And then notice x is linear, meaning it's not raised to a power, so this cannot factor, and we will leave it as x plus 2. The denominator of x squared minus 4, notice it is a quadratic. We check, do they have anything in common? No, but look at the pattern. We have a perfect square, and a minus sign, which instantly factors into x plus 2 and x minus 2. The last denominator is 5x cubed plus 2x squared. We always ask, do they have anything in common? And they do. At most, they have x squared in common. But notice x squared is really the same thing as x times x, and then 5x plus 2. 5x plus 2 cannot factor because 5x is linear. And so now we have that completely factored. Now we begin reducing. 5x plus 2's reduce. and x plus 2 reduces, leaving you with 2 in the numerator, and in the denominator you have x squared and an x minus 2, so that is your final answer. Example C, 7x squared over 6 divided by x divided by 2y. Now again, we are dividing two fractions, so you must multiply by the reciprocal. From here, we are now multiplying, which is top times top, bottom times bottom. Once everything's in the correct location, we begin to factor on the side of our paper. For 7x squared, we know that means 7 times x squared, but x squared really means x times x, so we expand it to look like 7 times x times x. Now looking at 2y, because they are touching side by side, that does mean 2 times y. 2 is prime and y is pretty simple, so we leave it as 2y. 6 is not prime. 6 is really made up of 2 times 3. And then we have x. X cannot be expanded. It is a simple x, and so we leave it as it is. Now we carefully want to reduce. We have x's that reduce, 2's that reduce, and that appears to be it. So your final answer is 7xy all over 3. What if you encountered a problem like this? Well, we know to merge them and get everything in the right location, and we reduce things that they have in common. But remember, the key thing is don't forget the 1 in the numerator. There is a big difference between having that 1 there and not at all. So please be careful. Here is your try it problem. Okay, let's see how we did. First, you should have multiplied by the reciprocal of the second fraction. From there, you merged them and expanded them according to how they factored. Reduced the values that they had in common. And your final answer should have been 3 times x plus 1 in the numerator, and in the denominator, x to the third times x minus 1.